You know, our cities are getting smarter all the time. We've got sensors everywhere, autonomous cars are on the horizon, and intelligent systems are becoming the norm. But this creates a challenge on a scale that is just astronomical. Today, we're going to dive into some new research that offers up a genius-level AI to manage the hyper-connected city of the future. Let's get right into it. But let me start with a question for you. What happens when all these smart devices start trying to talk at once? What happens when the sheer amount of information just becomes, well, completely overwhelming? What if our smart cities get too smart for their own good, and the very systems we built to make life better just grind to a total halt? That's the core problem we're talking about today.
And this potential chaos, it has a name: 6G. See, the next generation of wireless tech isn't just a simple upgrade. Oh no, it's a full-blown revolution, one that's about to unleash a tidal wave of data unlike anything we have ever seen.
The performance goals for 6G are, frankly, mind-boggling. It's being designed to handle 10 million devices in a single square kilometer. It requires response times under 1 millisecond. That's practically instantaneous, and it needs to be almost perfectly reliable. I mean, this is the kind of rock-solid performance you have to have for self-driving cars to coordinate perfectly, or for an entire city's infrastructure to make life-or-death decisions in the blink of an eye. So all this data, all needing to be processed instantly, creates what these researchers call a data tsunami. It's this overwhelming force that, if we don't manage it perfectly, could cause total digital gridlock. It could paralyze the very smart city it's supposed to empower. So the big question is, how in the world do you manage that wave?
Well, I can tell you one thing for sure. You can't manage it with the tools we have today. The systems we're currently using for network management, they just weren't built for the scale, the speed, or the sheer complexity of a 6G world. They're gonna fail.
And this slide, it lays out the problem perfectly. On the left, you've got our current methods. They're slow, they completely fall apart if you have more than like 50 devices, and they lead to all these uncoordinated me-first decisions that cause digital traffic jams. But on the right, you see what 6G needs: instant adaptation across thousands of devices, all making strategic, coordinated decisions. It's a total mismatch, right? We need a whole new toolkit.
And that brings us to the hero of this story, a new, four-part intelligent framework designed specifically to solve this massive problem. You can think of it as a genius brain for the entire network. Okay, its technical name is HGT-DQN-NEI. Yeah, I know, it's a real mouthful. It stands for Heterogeneous Graph Transformer Deep Q Network with Nash equilibrium integration. But don't worry about that alphabet soup. The key thing here is that it cleverly combines 4 totally different AI techniques into one seriously powerful system.
So let's break that down. Think of it like a team of specialists working together. First, you've got the network mapper, who sees the entire playing field. Then there's the fast learner, which helps every device get smarter on its own. Next up, the teamwork protocol, which makes sure everyone plays nice together. And finally, you have the ultimate balancer, who makes all the tough calls.
So first up is the network mapper, also known as HGT. This thing is basically the eyes of the entire system. It creates this constantly updating map that doesn't just see individual cars or sensors. No, it understands the complex relationships between them all. Which devices rely on which servers, which connections are getting jammed up. It sees the whole intricate web.
Next, we have the fast learner, or DQN. Now, this part is really cool. It essentially turns the whole task of managing the network into a giant video game. Every single device becomes a player that learns from trial and error. It gets points for good decisions and penalties for bad ones. So each device quickly figures out the best move to make in any situation, kind of like a gamer getting really good at a level.
But wait, what happens when you have millions of smart players all trying to win at the same time? You get chaos, right? Well, that's where the teamwork protocol comes in. It uses a concept from game theory called Nash equilibrium to get all those independent players to cooperate. It finds the most stable strategy where no single device can benefit by being selfish. It makes sure the entire team wins, not just one player.
And finally, we have the ultimate balancer. Because let's be real, it's not always about raw speed. The system has to juggle a bunch of competing goals. Should it prioritize getting a task done instantly, or should it try to save some energy? This final component is constantly running the numbers, weighing all those trade-offs to find the absolute best outcome for the network as a whole.
So, that's the 4-part genius brain. It sounds amazing in theory, right? But does it actually work? Well, the researchers put it through its paces, and the results are, to put it mildly, seriously impressive.
All right, let's talk speed. Compared to other top-tier methods, this new AI slashed the average time it takes to complete a task by over 23%. Now, that's not just a number on a chart. In a world with autonomous cars, that's the difference between a perfectly coordinated stop and a catastrophic pileup. It means a city that's faster, more responsive, and a heck of a lot safer.
It's also way more efficient. It improved energy use by almost 32%. Now, when you're talking about millions of devices running 24/7 across an entire city, that kind of energy saving is an absolute game changer, both for the environment and for the city's budget.
And it uses the network's resources much smarter. It boosted how well it used those resources by nearly 19%. What this means is the system isn't just throwing more power at the problem. It's using the infrastructure it already has more intelligently to get more done with less.
And maybe the best part of all is that it's practical. This AI learns incredibly quickly, hitting its best performance after just 30 to 50 training runs. And, crucially, it can scale up to networks with over 1,000 devices, which is a huge leap from the old systems that would just crash and burn at 50. This thing is ready for the real world.
Okay, so let's pull all this together. What does a technology like this actually mean for the cities we'll be living in tomorrow? How does it actually perform out in the wild? This table really shows you how adaptable the system is. The researchers tested the AI in all kinds of simulated environments, from quiet rural areas to chaotic, dense urban centers just packed with interference. And look at those performance scores. They stay remarkably high and stable no matter what they threw at it. This proves the system is tough enough to handle the messy, unpredictable reality of a living, breathing city.
So what does this technology actually unlock for us? Well, we're talking about the foundation for truly autonomous transportation, for smart energy grids that can predict and prevent blackouts before they even happen, for emergency response systems where police, fire, and ambulance services are all instantly coordinated. This AI is the brain that can finally make the promise of the smart city a reality. So this research gives us an incredibly powerful solution to a massive technical problem. It's a way to keep our connected future from collapsing under its own weight. We're looking at a genius-level AI that can orchestrate an entire city. But that also leaves us with one final, really deep question to think about. We know this AI can make our cities run better, but what rules are we going to teach it to follow? And maybe more importantly, who gets to decide?